So good morning to everybody, or good afternoon or good evening, depending where you are connecting from. My name is David Artuñeda. I'm working in Telefonica, and I'm running now a set of 5G trials in the south of Spain, in Malaga, where we have deployed a very unique and peculiar hybrid private and public 5G network that I'm about to describe right now. This initiative is promoted by Red.es, which is a program that was supporting the launch of different 5G trials across Spain. So the hybrid environment that we have built in Malaga, as I said, is unique in Spain. We have two areas: the university campus that you can see here on the right, where we have a full 5G network, private network with a private core. We're using the 5G new radio in 3.5 gigahertz and also millimetric waves. And we have also some MEC infrastructure, some edge infrastructure that we are managing with OpenNebula solutions that I will show you in a few minutes. This network covers the university campus, and we are testing some use cases there. I will show you one of them afterwards. We are testing virtual environments for teaching. We are testing also providing remote access to equipment in the labs that the students can use remotely. And also we are building now some solution for some virtual hospital so that the medicine students can perform some exams or some tests using some classes for virtual reality, and they go through a medical case that they need to complete in this environment. On the left, we see the second deployment that we have. In this case, is a shared infrastructure. We are using this infrastructure both for the commercial service, so Movistar users can connect to it, but also we are using the private PLMN to provide access to the Malaga police, so they can use this video monitoring system that they have connecting using 5G devices, and we will show you. I will show you again a couple of examples. So in this MEC infrastructure, we have a number of compute nodes that are managed by OpenNebula, and some of these nodes, they have some special resources, specifically GPUs, because the use cases that you will see, some of them use the GPUs for artificial intelligence processing, for image analysis, or for the students to use the applications that require the GPU support. One of the use cases that we've been trialing with the police is the people transit monitoring using artificial intelligence. The Malaga police have a number of cameras across the city, but we have added the possibility to put some mobile devices as cameras using 5G connected to this monitoring system. And we have deployed a number of applications that process the images that comes from these 5G devices, and they do video analytics in real time using AI to detect how many people transit in each direction for a specific public space. Okay. Another example is the crowd detection. In this case, the application is counting the number of people that occupies a public space, as you can see in this image, and I will do a demo afterwards. This algorithm identifies people and identifies cars. And we are collecting all this data in real time, and we are producing statistics to help the police manage better their resources based on the occupation that these public spaces are reporting using this type of tools. And the third use cases, this for the university, is providing access to a virtual desktop with GPU support using 5G as well. So the students in the campus, they can use 5G to connect to a virtual desktop, and they can work from any room in the campus or any area in the campus. They can work with this virtual desktop with a very low latency. We have just 4 hops between the 5G device and the virtual machine that the students are accessing to, just for network hops. And they can do all their work in this virtual environment. And of course, as I have said, it is supported by GPUs. So let's go for a demo now. First, I want to show you how we have this infrastructure deployed. We have here several hosts, as you can see. This third host have 4 different GPU attached to them. These are the NVIDIA RTX 2070. We have 1, 2, 3, and this is the 4th one. As you can see here, we have 2 virtual machines, that the 384 and 385, and again here, as you can see, some of them are using the GPU. This is a pool of virtual desktops that are pre-created so that when the students demand one of these virtual machines, they can access to it very easily. This here. So this is the web page of the Malaga University. I'm going to log in. And as you can see, we have here access to different devices. This is the regular or the non-GPU enabled virtual desktop for normal or for work that does not require GPU. This is the 5G GPU resource. And this is a special resource that we have created also for connecting to the lab, to the equipment in the lab. So if we launch this one, we are now connecting to the machine. Where is it? Yeah. This is the virtual desktop. As you can see, it has detected that it has an NVIDIA card, and here we can run some WebGL sample applications. Well, this one is detecting that it has an NVIDIA card. And for instance, we can run this sample. As you can see, we are running at 25 to 30 frames per second. We can increase the number of objects. The number of frames per second is more or less constant. We can increase the resolution of the objects, and still the frames per second continues to be very good performance, because this application is supported by the GPU. Okay, now moving to the next example. I'm going to show you now the AI-assisted applications that we have for the police. This is a dashboard where we can see we have a good number of cameras from the police that are counting people and counting cars. For instance, we can look at the last frame from this camera. It's a little bit dirty now because it has been raining in Malaga. But you can see we are detecting a car here, 2 people here. These ones are not detected because we are not detecting big trucks. We are detecting cars only. We can go to a public area, for instance, this one. So you can see we're counting people here, we're counting cars as well. We can go to this one as well. This one is more crowded. And all these numbers are being registered in a database so that the police knows the historic data of the occupation of the public places. The other one is the transit is controlled by this application, XPass. So we can look here at the last frame as well. As you can see, we're counting people here. This application is more challenging because it has to follow the people going by this area. It marks in red the people that are going from bottom to up of the street, and we are counting in green the people that goes from the up the street to the bottom. What we can show now is some animation based on the latest frames. So as you can see, these people now is being counted because it has go up, and these people that are coming here will go green because there is some imaginary line here that is the threshold to count the people. Okay. All right. So coming back here, a few takeaways. We've been using the solution from OpenNebula for quite a while now. It fits perfect for the management of the edge resources that we're using in these trials. It's very easy to install or very easy to manage. It provides us a system that let us create containers and VMs very easily. You have seen that we've been running virtual desktops as VMs in OpenNebula, but also we have container images for some of the applications. It's very easy to integrate these specialized resources like the GPUs. And one of the latest features coming from OpenNebula is OneStore. It's a very easy solution for storage. You get rid of all the complexity from Ceph or other more elaborated solutions. For a reduced number of hosts, you can share the storage with this OneStore solution with a very easy configuration. And I think I'm about 1 minute away from the deadline, so coming back to you, Michael.